This is a very interesting problem that a student sent to me, and I think that it is well worth discussing. Here we have a problem that says two boats leave a port at the same time, one traveling north and the other traveling south. The northbound boat travels at 8 miles per hour faster than the southbound boat. If the southbound boat is traveling at 21 miles per hour, how long before they are 225 miles apart? Okay, again, as we're working with these types of problems, these word problems, we really have to try and kind of jot down what we know, try to figure out what they're actually talking about before we, can really start in working the problem. So I know that after reading this, I'm seeing, I'm seeing that they're talking about miles per hour, which would be a rate. I see that they are talking about these boats being 225 miles apart, which would be a distance. And I see that the question that they're actually asking here is how long before this happens. So that's a time. So I'm trying to think of the things that would talk about rate and distance and time together. So that what comes to mind then is the formula that says distance equals rate times time. Okay, so now I'm now trying to kind of pinpoint it and make it a little bit more clear. We have these two boats that are traveling. So we have one boat that is traveling northbound, and we have one boat that's traveling southbound. Okay, the southbound boat is traveling at 21 miles per hour. So 21 miles per hour, that would be his rate. And it says that the northbound boat travels at 8 miles per hour faster than the southbound boat. Well, 8 miles per hour faster would have to be 29 miles per hour. So they've already told us their rate. Okay, let's look at each one of these individually. Let's look at our northbound boat again. Would it be fair to say that the northbound distance, oops, that's not very pretty, would be equal to his rate times his time? Sure. And we know what the rate of the northbound boat is. The northbound boat is 29 miles per hour. Now, we also know something about the southbound boat. The southbound boat's distance will equal their rate times time. And we know what the southbound boat's rate is also. That's 21. So now we know that the northbound distance would be 29 times t, and the southbound distance would be 21 times t. Now I'm going to use the same variable t for both of these because if you think about it, the boats are going to be, taking off at the same time. One's going north, one's going south. They're going to be traveling for the same amount of time whenever they are 225 miles apart. So their time traveling will be the same. So we can let it be the same variable. Alright, now let me write this out. Would this be a true statement? Would it be true to say that the northbound boat's distance plus the southbound boat's distance would equal their total distance? Absolutely. And we know the northbound distance is 29 times t. So that would be 29t. We know the southbound distance is 21 times t. So that would be plus 21t equals their total distance, which they told us up here was 225 miles. Now, let's go ahead and solve this equation. So we would have 29t plus 20t would be 50t equals 225. And then dividing both sides by 50, we get t equals 4.5. Now, what did t represent in our problem? It represented time in hours. So this tells us now that it's going to be 4.5 hours when they are 225 miles apart.